Today we are going to start with a new topic. We have studied about Pythagoras theorem involving right angled triangle. So let's start. Today we will discuss about Pythagoras theorem. We will solving the right triangle using Pythagoras theorem, which have formulas a squared is equal to a square plus b square. Start. Learning outcomes. What you will learn in this video, we shall be able to learn Pythagoras theorem, mathematical form of Pythagoras theorem, where to apply Pythagoras theorem, where not to apply Pythagoras theorem, identifying the correct name of the sides of right triangle, general examples, and examples relating real life stories. Then we will implement Pythagoras theorem in the real life stories. Then summary, and thank you host. So let's begin with the definition of Pythagoras theorem. The Pythagoras theorem is a fundamental principle in geometry that relates to the sides of a right angled triangle. You can see a right angled triangle. We know that the triangle has three sides. You can see on the screen there are three sides in the triangle, and they are named as A, B, and C. These are basically legs of the triangle. We call them in different way. We will learn these legs. We will give them names in different ways. Actually, this theorem is attributed to the ancient Greek mathematician Pythagoras, although it is likely that it was known to mathematicians in various cultures long before his time. It has vast applications in various fields, including trigonometry, physics, engineering, and even computer graphics. Mathematical form of Pythagoras theorem. Now we will discuss the mathematical form of Pythagoras theorem, that the formula you have seen in the previous slide. It states that in a right triangle, the square of the length of the hypotenuse is basically the side opposite the right angle. This is a right triangle. You can see that there is a perpendicular line that makes an angle of 90 degree. The opposite side of that angle 90 degree is basically hypotenuse. The side opposite the right angle is equal to the sum of squares of the lengths of the other two sides. You can also see other two sides that we named as A and B. So these are A, B, and H. Mathematically, it can be expressed as H square is equal to A square plus B square. H means hypotenuse, and A and B are the legs of the right triangle. C is the length of the hypotenuse, A and B are the lengths or legs of the other two sides. Right triangle. We know that we have learned about that right triangle has three different sides and three different angles. We solve these sides and angles in different ways. So we have two methods to solve a right triangle. One is Pythagoras theorem and the other is trigonometric ratios. Now the question arises that when do we apply Pythagoras theorem and when do we apply trigonometric ratios? It is very simple. When we are discussed only the sides and not any other angles are discussed, like there in a right triangle, it is must to have a 90 degree a right angle. So if other two angles are discussed, we will apply trigonometric ratios to find that angle or side. Or meanwhile, on the other hand, when no angles are involved other than right angle in the right triangle, we will apply Pythagoras theorem. Pythagoras theorem will be applied using the formula c square is equal to a square plus b square. When both of the angles are involved with right angle in right triangle, trigonometric ratios will be applied for finding different angles and sides. Like sine theta is equal to opposite over hypotenuse, cos theta is equal to base over hypotenuse, tan theta is equal to opposite over base. Basically, this is not opposite. This we also called it as altitude or perpendicular. So we will also name these opponent and hypotenuse in different way. Let's discuss these opponent, base and hypotenuse in different ways. We have here two triangles. This is one and this is another triangle. We can easily say identify that these both are triangles are right triangles. Now we will discuss we will identify base opponents in these two right triangles. In the first triangle, having P as a perpendicular is on the floor and base is vertical, and hypotenuse is obviously opposite to the right angle, that is edge. When other angle is given other than 90 degree, the opposite side of that other angle theta will always be perpendicular. Like in the first left hand side right triangle, it represents perpendicular on the base because it is opposite to the theta, that is any angle in the right triangle other than 90 degree. On the other hand, when we see on the right side, base is on the floor because the theta is opposite to the perpendicular, is always opposite to the perpendicular, and hypotenuse is always opposite to the right angle, that is 90 degree. Now let us an example of right triangle. Here is a real life example of the application of the Pythagoras theorem. You can see a figure here. The question is, if a ladder is placed with a vertical wall making an angle theta, the distance between the lower side of the ladder and the wall is b is equal to 3 meter. It means that the distance is 3 meter and named as b, and the height of the wall is a, that is equal to 4 meter. We have to find the length of the ladder inclined with the wall. As we can see that the wall makes an angle 90 degree perpendicular angle with the floor, so the opposite side h will be the hypotenuse, that is opposite to the 90 degree or perpendicular angle. So we also can see that the ladder is making an angle theta with the floor, so the opposite side of this theta will be opponent, that is a, opposite, that is a, and the base will be on the floor. So let's solve this question. According to the Pythagoras theorem, h square is equal to h square plus b square. Put all the given values. We will put a as 4, b as 3. After taking the squares, the sum will becomes 25, and after taking the square root on both sides, h becomes 5 meter. Thus we can conclude that the length of the ladder is 5 meter. Lesson summary of today's lesson. In this video, we learned about the concept of Pythagoras theorem, mathematical form of Pythagoras theorem. We discussed about where to apply Pythagoras theorem and where not to apply the Pythagoras theorem, because we also have another method to solve a right triangle, that is trigonometric ratios. We discussed about legs and sides of right triangle. We discussed a real. Thank you for watching this video. If you found this video helpful, don't forget to like, share and subscribe to TheCAGSMentor for more educational content like this. And if you have any question or any topic you would like to see covered in the future videos, feel free to leave a comment below. Thanks again for watching, and until next time, happy learning.